In this lesson, we're going to be solving this problem. This problem is under volume expansion. The problem reads as follows. A cast iron block in a form of right rectangular has a dimensions 40 millimeters by 50 millimeters by 60 millimeters at 290 Kelvin. Calculate the volume at 400 K. That they are looking for the final volume. Here a coefficient is a linear coefficient. So here let me write the data that we have. Remember, this problem is under volume expansion. It's under volume expansion. So here this volume they are looking for at this temperature. That means the final volume. So let me write the data that we have from this problem. Separate here. Then we have the initial volume, which it is 40 millimeters by 50 millimeters by 60 millimeters. Then this divide by 1,000, this divide by 1,000, and also this divide by 1,000. Convert it into meters. Then here it's gonna give 0.04 meter times here it's gonna give 0.05 meters. Here it's gonna give 0. Here times 0.06 meters. Then the initial volume it's gonna be, when you times all this, it's gonna be 1.2 times 10 to exponent -4 cubic meter, like this. That's the initial volume of this cast iron block. Then from here, let us write, we've got the temperature 1 in Kelvin is 290 K. We've got the temperature 2 in Kelvin is 400 Kelvins. Then we've got the linear expansion coefficient. It is 9.8 times 10 to exponent -6 per Kelvin. We're looking for a final volume. That means because we're looking for a final volume, so we have to say final is equal to a change in volume plus the initial volume, which is this. So here we have to find this change in volume. But before we find this, we have to find the coefficients for a volume. So a coefficient of a volume expansion, it is 3 times of the linear expansion coefficient, like this. Here is the coefficients for the volume. It is 3 times of this linear expansion. Then we'll say 3, then we put the coefficients for linear expansion, which is this 9.8 times 10 to exponent -6. Then this it's gonna give 29.4 times 10 to exponent -6 per Kelvin. This is the coefficient for volume expansion. So let us come this side to calculate the change in volume. Its formula, it is change in volume is equal to then the volume expansion times the initial volume change in temperature. Then here, then the initial volume here, this that we got it here, it is 1.2 times 10 to exponent -4. Then the change in temperature, it's gonna be 400 minus 290, like this. When you calculate all this, it's gonna give you the change in volume to be 38.808 times 10 to exponent -8 cubic meter, like this, because the volume it's in cubic meter. That is a change in volume. Now we come back into this formula because we have this one, the initial volume, which is the original. Now we found the change in volume. That means we can find the final volume at this temperature. Because now we've found the change in volume, this one, now we have to take this change in volume and add here in a original volume. So let us find the final volume. We'll take this formula it is volume final, it is equal to, then the change in volume, this one you just got it now, it is 38.808 times 10 to exponent negative 8, then plus you put the initial volume. The initial volume, it is this one here, take it from here, it is 1.2 times 10 to exponent negative 4, like this. Then here the answer that we get here, it's gonna be cubic meter, 120.388 cubic centimeter, like this, in centimeter. Here it is in meters, you can change it into millimeters, but I was just showing you that's how you add to find the final volume, because here the statement said you must find the volume at this temperature. That means it is a final volume, this one that they are looking for at this temperature. So to find the final volume, you must find, because originally from this temperature to 290 kelvins, it was this initially this dimension here at this temperature. Now because of the heat increase to this temperature, now there is a new volume, which is because it extended here with this change in volume. Then we have to calculate the change in volume from this dimension to that change in volume that small volume is added here. So then we find that change in volume, we take that change in volume, we add to a original volume that we got it from this to this one, original volume from this dimension, this one, add to it this and that new, the change in volume, then we find the final volume. Here it is. Then you can change it to centimeters cube if the statement said change it to centimeters cube.